Hi, it's Carly McAvoy. I'm going to work through the following factoring problems in the fall of 25. They are on a practice midterm for my class. They could be on a different test, a final exam, or midterm, and they could have different numbers, but these problems should remain the same. So when I have a problem like 17, I want to find two different binomials that multiply to equal that, and I use the box method, so I'm going to use that here. In my box method, I put my first term over my first column. I put the last term, including the sign, over the second column, and I put the middle term down below, and I always include the sign, even if it's a plus or minus. That's going to help me get this correct. So for y squared, these two things below it have to multiply to be y squared. The only thing you can use is y times y. And then for 36, these two numbers have to multiply to equal 36. And they're actually going to end up equaling negative 36, but I can deal with that in a minute. But look at the factors for 36. 1 times 36, 2 times 18, 3 times 12, and 4 times 9, 6 times 6. All those are possibilities, but what I want is to end up with 5. And so if you look at these pairs, there's only one pair that this 4 and 9, 4 times 9, that seems like it could get me to 5. So I'm going to do 4 and 9. And then I'm going to multiply straight across. That's going to give me 4y and 9y. And I want to say, well, I want these two things to add up to be positive 5y. So if 9 was positive, but 4 was negative, then I could get that to add up correctly. So I never put a negative in this first column. Always my negatives, if there is one, goes in the second column. And you can see that negative 4 times positive 9 is going to be negative 36. And negative 4y plus positive 9y will add up to 5y. So that's going to be my answer. It doesn't matter when you have y, the same term in the front, but it will matter later when you get different terms that you find the answer on the diagonal. So y minus 4 is 1, and y plus 9 is the other one. It doesn't matter which term you put first. If you put y plus 9 first and then y minus 4, but the signs are important. So wherever you put the 4, it should be a minus, and where you put the 9 should be a positive. Okay, and this is a factor by grouping problem, and we're going to group these just as they appear. As you get into more complicated math, you'll have to rearrange in order to factor, but I'm not doing that. So we're just going to go ahead and group these two. Notice that I put the negative with the 2x. That negative goes with that sign, and we always have a plus in the middle. Then I want to factor out the common factor, and the common factor for these two is y. That's like dividing both of these by y. And so you get x minus 5 with a y out front. I didn't write that very nicely. And here I want to take out the common factor, and I never want my lead term to be negative. So I'm going to take out negative 2, and so I'm actually dividing both of these by negative 2, and that gives me positive x and negative 5. Notice that I have x minus 5 exactly matching in both of these. So that's my common factor. Now this binomial is the common factor, so I can take that common factor out. Think about that as dividing both of these by x minus 5, and what's left? Well, in the first one I have the y left, and in the second one I have the minus 2 left. And remember, you can always check your factoring by multiplying. If I take x times y, I would get that xy term. Negative 5 times y would give me this term. X times negative 2 would give me that term, and negative 5 times negative 2 would give me 10. So foiling that out, I should get back to all the correct terms. In this problem, we're going to use the idea that we should always take out the common factor first, because I can see that 4 goes into both of these terms. So I'm going to divide both terms by 4, and that's going to give me x squared minus 4. Now I want to look at, whenever I have two terms, do I have a difference of squares? And I do, because x times x is x squared and 2 times 2 is 4. So that's going to, my 4 is going to come down. I don't want to leave that off. If I taking that out, that's part of my answer. And then I'm going to factor these. X squared goes into the first two spots, that is x times x. And 4 goes into the second two spots, that is 2 times 2 minus and plus. And I could FOIL that back out and then distribute that 4 and get back to what I started with. I can always check by using multiplication. So that's 3 different methods. We have a trinomial, we have a factor by group, and we have difference of squares. Down here, we have a harder problem because it has a common factor. So we have to take out the common factor. And if you look through there, the common factor is 2. So I'm going to take that out first. I always want to take the common factor out before I use any other method. That's going to leave 2x squared minus 9x and minus 5 because we are dividing each of those terms by 2 and putting that 2 out front. Now I want to put this into my box, but I don't want to forget this 2. That's a really common mistake. So I'm going to do this. I know my answer's got to look like this. If it's factorable, I'm going to have a 2 up front and I'm going to have 2 things there. If you write that down ahead of time, you won't forget to do it later. All right, so my box is going to look like this. My first term, which is 2x squared, is going to go over the first column. My last term, which is minus 5, goes down there. And down below, I have the negative 9x. And then I have to think about what can I do to get 2x squared, and that's going to be pretty straightforward, 2x and x, because 2x times x would be x squared. We multiply up to get the number on the top. And for 5, I'm going to have 1 times 5. But you have to be careful because do you put the 1 up top or the 5 or the 5 up top? And so how I can think about that is I want to get all the way to 9. And if I put a 1 up here, that would be 1 times 2 and 5. It's not going to get me there. But if you use a pencil and if you put 1 and 5 and it doesn't work, then you erase them and then you try 5 and 1. So sometimes it's obvious, but sometimes you kind of got to guess and check and see what's going to work. So multiplying across, I have 10x, and multiplying across, I have 1x. I'm just going to write that as x. Now remember, I want this to be negative 5, so one of these has to be negative. And when I look over here, I see if I added these together to get a negative 9, I would have to have negative 10 and positive 1. So my 5 is going to be negative. And so then I want to make sure that I get my answers on the diagonal, but I can do a quick check, just really quick. 1 times negative 5 is negative 5. 2x times negative 5 is negative 10. 1 times x is 1, and if I add those together, I do get negative 9x. So I feel pretty good about that. On one of my diagonals, I have x minus 5. And on the other diagonal, I have 2x plus 1 because I don't see a sign, that I'm assuming that that's a positive. And then for my last one here, I can't factor out a common factor because there's nothing in common here. So it's just going to be a little bit harder because I have for 12, I could do 2 and 6, or I could do 3 and 4, 1 and 12. There's options, and for 6 I also have options. So that's when it's nice to use a pencil, and then if you make a mistake you can erase and try again. So let's say that let me set my box up here though. I have 12x squared, and then I have a minus 6 and I have a plus x. Let's say that I want to guess and check this. So I try 3x and 4x because 3x times 4x is 12x. And I want this to be positive x down below, yeah. And then I say, I don't know, what if this was, let's say, 3 times 2. No, don't do that because I think that's going to solve it for us. Let's say I said, what if this was 1 times 6? Well, 1 times 6 would be 3x and 24x, and that's never going to get me to where I want to go. So I don't like the 1 and 6 option. So let me try 2 and 3. And let's say that I put 3 here, put 2 here, and 3 there. Well, that's going to give me 6x and 12x. And again, that doesn't get me close to that 1x. So no, but I don't want to give up on 2 and 3 yet. I want to try, what if I change those places so that I put the 3 up above and the 2 down below? Now I have 9x and 8x. And you can see that that gives me the possibility of getting to that 1x. So this is what I think it is, 3x and 4x here, and then 3 and 2. But remember, we have a negative 6 up here. So If I wanted to get positive 1x, I would want the 9 to be positive, and I would want the 8 to be negative because I want one more positive than negative. So my negative goes right down here. And then my answer is going to be on the diagonal. And so I have 4x plus 3, and I have 3x minus 2, because that's my second diagonal. And then again, I could FOIL this out to check it. You can always check 4x times 3x is 12x squared. My last term's 3 times negative 2 is negative 6. And in between, I have 9x and negative 8x, which adds up to x. So that's factoring, and I will talk to you next time. Have a fantastic day.